Here we're going to look at some density problems. So we're going to start with easy ones and work our way to a little bit more difficult ones. So starting with number 1 here, so I have 2 on the whiteboard. The first one's asking us to calculate the density, giving us 5.0 grams of solution that has a volume of 7.3 milliliters. All right, so in order to do this, we need to know the density equation. So density, if you watch the PowerPoints, is equal to mass over volume. So if we're calculating density, we're going to need to take the mass and divide it by the volume. So if it doesn't particularly tell you what these values are, you would be able to figure out which one is mass and which one is volume based off of the units. So G, grams, that's a mass. ml, that's milliliters, that's a volume. Okay, now for the 5 grams, it doesn't tell us that's a mass, so we'd have to use the units to figure out that that's what m is equal to. For the volume, it specifically tells us the volume is, but if it didn't, the ml, milliliters, the units on it would indicate that it's volume. So all we need to do is plug in, putting the mass on top and the volume on bottom. Since I'm dividing, when I'm counting sig figs, I'm going to look at the numbers as a whole. So I have 2 sig figs in 5.0, 2 sig figs for 7.3, so my answer should also have 2 sig figs. So when I'm writing out my answer, when I calculate it, I get 0.6849 and a whole bunch of other numbers. But I just said I wanted just 2 of those numbers mattered. So the 6 and the 8. Look at the number next to it. That's going to stay an 8. So 0.68 is my answer. But I also need units. What are my units? Right there. Grams per mil. So G/ml. Let's try another one. So the next one is asking us to calculate volume. So it says, what volume? So volume's my question. So volume's what I'm solving for. What volume will 10.2 grams of benzene occupy, given that benzene has a density of 0.879 grams per mil? Okay, so it's telling us this 0.879, that's my density. So what is this 10.2? Looking at the units, G for grams, that tells me that's my mass, because mass is measured in grams. So I can still use the same equation. And remember, the equation is density is equal to mass over volume. But this time, I'm solving for volume, the V. So I need to rearrange that equation to solve for volume. Now there's actually a trick to doing this with this density equation, and it's the density triangle. And if you watch the PowerPoints, you would have seen this on the PowerPoints as well. And with this density triangle, we just take this equation and we plug it into this triangle that I just made. So D, M on top, V down there. So D, M, V. So how we use this is we use it to help us figure out how to rearrange that equation. So this vertical line is a multiplication. This horizontal line is going to be a division line, just like if it were a fraction. So how I use it is whatever I'm trying to solve for. So in this case, volume is what I'm trying to solve for. I'm going to cover up that variable with my hand. So solving for V, I'm going to cover that up. Then I'm going to do whatever the triangle tells me with the other 2 variables. So what this is telling me is it's going to take the mass and divide by the density. So to solve for volume, the rearranged equation would be mass divided by density. So now I just need to figure out what my mass is and what my density are and plug those in. We already did that. We said the mass is this 10.2 grams, and we know that because of the fact that grams, the units, is a mass. The density is 0.879. per mil. Now, another thing when you're doing this, make sure that your units are matching. So what I mean by that is I had grams for my mass. My density was grams per mil, grams. So if one of these were in kilograms instead, I would have to do a conversion before I could plug them in. Because I want my grams to cancel, because I'm solving for volume. Grams is not a unit on volume. Milliliters is the unit on volume. So I need my grams to cancel, leaving just milliliters. Now when I divide those out, notice each of those numbers has 3 sig figs, so I should have 3 significant figures in my answer. And I'm going to get 11.6 milliliters. Let's look at 2 more density problems. So the first one, we have the density of ethyl alcohol given here. Calculate the mass. So our mass is going to be our question mark now of a 30 milliliter sample. So I'm going to write my density triangle over here. Let me do it over. Help me figure out what my equation is going to look like. DMV. This is a multiplication, and these are divisions. Okay, so what do we got? First off, this 0.789 grams per mil. That's my density. It says it specifically here. If it didn't, I would know that because of the units. So D is equal to 0.789 grams per mil. Calculate the mass. So mass is my question mark. That's the variable I want to solve for is M. So when I figure out how to rearrange the equation, I'm going to cover up the M with my hand. The last piece, 30.0 milliliters, it doesn't tell us what that is, but since the units are milliliters, I would know that that is a volume. So these are the 2 values we're going to plug into the equation. But what does the equation look like? Well, mass is what we're solving for. So M is equal to. So I'm going to cover up the M. It tells me to solve for mass, I'm going to take my density and multiply it by my volume. So plug in my density where the D is, 0.789 grams per mil. I'm going to multiply that by the volume, V, which is 30 milliliters. Notice I need to have the same units so that my milliliters cancel, right? I have milliliters up in the numerator. I also have it in the denominator. So opposite sides of the horizontal line, those units cancel. Now, once I multiply these 2 numbers, my units will be grams. And that's what I want because mass is measured in grams. When I solve this, once I multiply those 2, both of them have 3 significant figures. So I'm going to want 3 significant figures in my answer. Rounding up, I would get 23.7123, and the units are grams. So units are very important. If you don't know the units, the number's meaningless. Let's try this next one. So in this next one, we're looking at ammonia. We're given a density, grams per mil. We're calculating mass once again. Okay, so we're going to be using that rearranged equation. And then I'm assuming this is going to be a volume. So let's go ahead and label these. So this number here, that's my density. This number here, that's my volume. And I know that because of the units. Liters. Liters is a unit of volume. If I'm solving for mass, it's that same equation that I used in the previous one. So it's density times volume. But before I plug these numbers in, I notice something. And what I notice is that the units between the 2 are different. I have milliliters on top. So grams per milliliter for the volume portion. For volume, I have liters. I need them to be in the same units. So what I'm going to do, it's going to be easier to convert the volume. So I'm going to convert this to milliliters. And I'm going to do that. It's a metric to metric, liters to milliliters, right? Liter, liter in common. So I can use that. King Henry died drinking chocolate milk. In this particular case, that empty space is going to be the letter that's in common, so liters, since we're talking about volume. Liters is where I'm starting. Where I want to be is at milliliters, the M over here. So to get there, I'm going to move the decimal 1, 2, 3 times to the right. So do the same thing up here, starting with the original number. I'm going to move it 1, 2, 3 times to the right, and then add zeros in those spots. So this goes from 6 liters, is equal to 6,000 milliliters. So this is the number I'm going to want to plug in as my volume, since it's in the correct units. So solving, I'm going to plug in my density, which is 0.000771 grams per mil. Multiply that by my volume, the converted volume of 6,000, because that's the milliliters. Now that they're both milliliters, those milliliters cancel, leaving my units as just grams. Multiplying this out, 771 times 6,000, I get 4.626. How many sig figs do I want? Well, I want to look at my original numbers, okay? So in this top number, I have 1, 2, 3 sig figs. 6.0, I have 1, 2. That 0 counts because there's a decimal, and I started counting at the 6. So that means I want 2 in my answer, because I always pick the smallest. So I go down here. 1, 2, stop it there. That remains a 6. So my correct answer to the correct sig figs will be 4.6, and the units are grams because it's a mass. So if I weighed that 6-liter sample of ammonia, it would weigh 4.6 grams on the scale.